Miss Jackson coming to you with another video.
Alright, changing the value of b in the equation y equals a sine of bx plus c plus d affects the period of the function. When the absolute value of b is greater than 1, the graph experiences a horizontal shrink. When the absolute value of b is less than 1, the graph experiences a horizontal stretch. Alright, so I'm looking at my b value, which is 1/3. Remember, that's the coefficient in front of the x. So I see that the absolute value of 1/3 is less than 1. So my graph will experience a horizontal stretch. And that means that the period is going to be longer than the period of the original sine function. So I have 2 pi divided by the absolute value of b is 1/3. So it's 2 pi divided by 1/3. I'm going to keep the 2 pi, change the division to multiplication, and then reciprocate the 1/3. So the reciprocal of 1/3 is 3/1. And if I put the 2 pi over 1, I just multiply straight across. I get 6 pi divided by 1, which is just 6 pi. So my period is going to be 6 pi. And remember, my original or my parent graph or the parent sine graph has a period of 2 pi. Okay. And this also means that my angles are not going to be the same as my angles for my original parent graph because my period changes. So I have to find the 5 key points on the graph. So the 5 key points are the points the x-intercepts, the max and the min points. So what we're going to do, we're going to take the period and we're going to divide it by 4. And I always do this little number line to help me find the new angle. So let me take the period. The period was 6 pi. If I divide that by 4 and reduce it by 2, I get 3 pi over 2. So we're going to go from 0 to 3 pi over 2. So I meant to say we're going to go from 0 to 6 pi. So 6 pi is the period. That's one cycle. That's the graph of one cycle, one period of this function. So I like to think of this as a line segment, and I'm going from 0 to 6 pi. But I'm making I'm dividing this segment into four parts. So I'm going to make 4 stops. So it may not be equal parts, but it's supposed to be equal parts. So you can actually think of it as being equal parts, but it's not. So each part has a distance of 3 pi over 2. That's my increment. So it's taking the distance of this line segment, which is 6 pi, and dividing it by 4 parts. So each part should be 3 pi over 2. Should have a distance of 3 pi over 2. So I'm riding my bicycle and I'm starting at 0, starting at home, and then I'm going to go 3 pi over 2 distance. So that means my first stop would be at 3 pi over 2. Okay, if I travel to the next stop, then I have to add 3 pi where I'm starting from, 3 pi over 2, and add another 3 pi over 2. That's going to give me 6 pi over 2, which is just 3 pi reduced. All right, if I go into the third distance or the third stop, then I need to add 6 pi over 2 and 3 pi over 2, and that's going to give me 9 pi over 2. And if I go to the fourth stop, then 9 pi over 2 and 3 pi over 2 is actually 12 pi over 2, and that reduces to 6 pi. All right, so these would be 0, 3 pi over 2, 3 pi, 9 pi over 2, and 6 pi would be my new angles. for this graph. All right, so I create a t-table for those values, and I am going to substitute those values in for x in my function. So I have sine of 1/3 times 0. So that is the sine of 1/3 times 0 is 0. And I know that the sine of 0 is 0. All right, the sine of 1/3 times 3 pi over 2. Well, this is just the sine of 3 pi over actually 6, which is the sine of pi over 2. And I know that is 1. Then I have the sine of 1/3 times 3 pi. Well, this is the sine of 3 pi over 3, which is the sine of pi, and that is 0. So you should see a pattern here. So it's going to be probably 0, 1, 0, -1, 0. But we're going to continue with the table. So I see sine of 1/3 of 9 pi over 2, which is the sine of 9 pi over 6, which reduces to the sine of 3 pi over 2. And I know that the sine of 3 pi over 2 is -1. And then I have the sine of 1/3 times 6 pi. And that's going to be the sine of 6 pi over 3, which is the sine of 2 pi. And I know that the sine of 2 pi is 0. So again, my y values are going to be 0, 1, 0, -1, 0. Okay? And then my last step is to create a graph. Okay, so I have my coordinate plane with my angles, and starting at 0, I am at 0. At 3 pi over 2, I am at 1. At 3 pi, I'm at 0. And at 9 pi over 2, I'm at -1. And at 6 pi, I am located at 0. So again, my function is this graph. Okay? And that's it.